Hello. Hello.
No, there's only like, but I'm not sure if it will work with this. To keep it like higher a little bit, but it's probably, I don't think, probably you have to just speak like this to actually be heard. So if David will find something to keep, if not, I will keep it just.
It's not great, but
But is it okay?
it's better.
Could you try to speak?
Hello? Can you hear me?
I don't think the mic is. But probably we can hear, and everyone can hear. Yeah, better.
It's either this or you holding the mic.
Yeah.
It's not.
Still 4 minutes. It's not perfect. I think it's like we have those mics that you can pin, but they are not working, so it's still. It's just like we don't have any mics. We have also these cards that are saying that you have 2 minutes left, so we'll show you.
Oh, yeah. Awesome.
Where you will be sitting with cards. Yeah. So we'll just show you. You can not. Yeah.
I'll just try to talk very loud and hopefully it will pick it up.
Yeah, I feel like it's something is picking up, but not a lot. I think yesterday almost no one was looking at the stream, but today we have some viewers that are connected to the stream. So might be good too.
Does it also end up on YouTube or is it only for streaming?
I think it's only for streaming. Did you agree to any recordings?
I don't recall.
Yeah, I think it's only streaming. There is no. No recording that will be there. Netherlands, oh really? Which city? Amsterdam?
Almere currently. And moving to Zutphen.
I was in Utrecht.
Utrecht, yeah. Not too far from that now. Yeah.
What is the weather in Netherlands? Like rainy most, or
Well,
I was there.
it was really hot when I left.
Everyone was closed because of the heat wave. So it
Yeah.
was unexpected.
But it's similar to here right now, I think. It was hot and now
Yeah.
it's like
Yeah.
good 20 something.
Yeah. But I love biking routes
Mm.
everywhere.
Yeah.
Yeah, that's very nice.
That's what we're known for.
Do you like biking?
Hmm?
Do you like biking?
Oh yeah.
That's good. Okay, hello. I think we can start. Let's welcome Almar Klein with his talk about interactive visualizations and anywhere. Yeah, please welcome. And I think I will keep this, for, yeah, I think, no, don't worry.
Okay.
Just, yeah.
So we have a bit of a problem with the microphone and I'm live coding, so I need my hands. So hi everyone, my name is Almar Klein and I've been doing visualization for most of my Python career. And like in the past few years, I've been working on a package called PyGraphics, which is a GPU-based render engine with a high focus on performance. And it's a generic render engine, but it has a couple of features making it very suitable for scientific applications. So we have users using it for interactively exploring very large time series data or volumetric data sets of massive sizes, stuff like that. And our users, we have like some users that are using the notebook to do their data explorations, and other people use VS Code or another IDE. We've put people running code on heavy machines in the cloud and want to visualize the data locally. And we kind of want that to work in all these different environments, and we want it to work interactively. And that is a problem that we've solved with a library called Render Canvas. And that's also the topic of this talk. So Render Canvas solves a problem where basically the idea is you have some code, your user code, and if you zoom out or zoom in all the way, I guess, what every interactive visualization is doing is it's rendering and it's reacting, right? Even if you just have a plot, it generates the plot, and then if you use the mouse to zoom in and out and pan the plot, that's basically what you're doing, and you can bring down any interactive visualization to this model, basically. And what you want to do, if you have done the rendering, you want to sort of present that to the user in one way or another. So you want to push that image to the canvas. And but you also want to react to stuff, so you also want events going the other way. And with canvas here, I mean like the abstract thing. It's basically a rectangle on screen somewhere. And yeah, this is kind of the model that I want, that's sort of the takeaway of this talk, and which is also like the whole idea behind Render Canvas. And we want this rendering code over here to not care how this is happening. We just want to write the code and then have it working, just have it work anywhere. That's the premise. And yeah, the rest of the talk is really just to like a demo to sort of show this in hopefully a fun way. And what I'm going to do is I'm going to code a little game, and I'm going to cut like every corner that I can. So one of the corners that I'm cutting is that I've implemented the game logic already in a small library. So I'm importing that. So we can instantiate the game object and have the game. We'll look into that later. Next, we need a canvas. So we're going to import render canvas. and an event loop. Instantiate the canvas. And we're going to tell it to sort of continuously render rather than, for instance, on demand. Oh, forgotten this. So for this talk, I'm going to use Visual Studio Code's notebook support to actually create a canvas. So here's the canvas that we're going to use. And yeah, so it doesn't show anything yet. So the first step is to actually show something in the canvas. And for that, we're going to create a context object. And render canvas supports two ways to render to it. So you'll see, if you are used to web development, you will recognize this idea of having a canvas and a context that you're used to, to push an image to it in one way or another. And we have like two contexts. One is GPU based, so that's what we use in Pi graphics, and one is bitmap based, which basically means you create an NumPy array in whatever way you want, and then you push that array to the canvas, and that's where it's shown. And you can use, for instance, Pillow or a tool like that to create an image and populate it with text and lines and circles or whatever. Convert that to a NumPy array and push that. But in this talk, I'll just really create a zeros NumPy array and populate it a little bit and send it to the canvas. So yeah, so that's what we're going to do next. So we're going to tell the canvas that this is the function that it needs to call whenever it needs a new draw. So this function right here, this animate function, is going to be called 30 times a second or more if you want. And this we'll start by using the context object to get the width and height of the scene, of the canvas. And also the pixel ratio. And the pixel ratio is just a number to sort of scale up and down. Like if you are on a retina screens, you have much smaller pixels, and you want to sort of compensate that so that sizes are consistent. Yeah, so now we basically have